So now we are finding the volume of a region using cylindrical coordinates. Okay, so here we have a paraboloid and we have a plane. So the given surfaces um, x square plus y square equal to 4 minus z, or simply we can write this as z is equal to 4 minus x square minus y square. Alright, so we can see it is a paraboloid because one side degree is 2 and one side degree is 1. And since this is negative, so the paraboloid will be facing down. So when x equal to 0, y equal to 0, on z axis, it will touch z equal to 4, right? So we will try to sketch the region, step 1, sketching the region. So here we have a x, y and z axis. So this is my x, this is my y, x, y and z, right? And on z axis, the paraboloid is touching at 4. So I will just draw a paraboloid facing downwards, which is looking like a bell. And the lower limit, one limit is z equal to 0. That means xy plane. So xy plane is z equal to 0. Alright, so now I have to imagine a cylinder. So when z is equal to 0, from here, we can see the basis, or we can say that 4 equal to x square plus y square. That means the base is looking like a circle of radius 2. So I will take an imaginary cylinder now, something like this. An imaginary cylinder that encloses the region tightly. Okay, so the radius of the cylinder should be 2 because of the base. So we will use cylindrical coordinates. So cylindrical coordinates, as we know, that is x is equal to r cos theta, y equal to r sin theta, and z is equal to z, right? And in this case, the Jacobian, as usual, is always r, and we know that radius of the circle should be 2. So 0 less than r less than 2, 0 less than theta less than 2 pi, because we require entire circle in the base. Now if we take these limits, so it will give me the entire cylinder, but I want only a portion of it inside, right? So what I will do here is I will take a strip which is parallel to z axis, and we can see the lower end of the strip is resting on the xy plane and the upper end of the strip is resting on the paraboloid. So here z is equal to x square minus 4 minus x square minus y square, and when I put x equal to r cos theta, y equal to r sin theta, this will be just 4 minus r square. Alright, so the limit for z will be 0 less than z less than 4 minus r square. Alright, so now the volume is triple integration dz dx dy dz, and since we are doing the change of variable, so it will be triple integration r. So we can take anything anywhere, so we will take d theta first, then we will take dz because, and then dr, because z is depending on r. So this is a Jacobian d theta dz dr. So limit for theta is 0 to 2 pi, limit for z is 0 to 4 minus r square, and limit for r is from 0 to 2. Alright, so we will evaluate them one by one. So finally what we get is equal to integration 0 to 1, 0 to 4 minus r square into r, 0 to 2 pi d theta dz dr, right? So the answer of this integral is 2 pi integration 0 to 1, 0 to 4 minus r square r dz dr, right? So now r is a constant for z, so it will reduce to 2 pi 0 to 1, and r as it is integration 0 to 4 minus r square dz dr. So if we evaluate this integral, it will be z, then upper limit minus lower limit. So finally we can write it as 0 to 1 r, this will be 4 minus r square dr, and finally it is 2 pi integration 0 to 1 4r dr minus integration 0 to 1 r cube dr, right? So this is 2 pi, and this will be 4 r square by 2, 0 to 1, minus r is to 4 by 4, 0 to 1, and this 2 gets cancelled, so 2 pi, and finally 2 minus 1 by 4, or 2 pi 8 minus 1, that is 7 by 4, or similarly simply we can just cancel the things out 2 times, so that is 7 pi by 2. So that is the answer, and this 7 pi by 2 is nothing but the volume of this region using cylindrical coordinates. Okay, so the answer is pretty simple in this case. Thank you.